Hello everyone. So in this video I am going to discuss about the computer network concepts. So I will come with a series of around 1,000 questions that is from the computer network subject, and these series of the lectures and the questions that will be helpful for uh, gate examination and also the UGC net for the postgraduate students. This is for the postgraduate and this is for the UG, and also uh, KEA Karnataka Education Authority, they are conducting for the recruitment of assistant professor. So these questions will help for those students. Okay, so we'll start with some of the basic questions. So a data communication system has how many components? Okay, so a data communication system, it has total 5 components. Data communication system has 5 components. So what are those components? That is message, the data communication. So it is a process of transferring the data that electronically from one place to another. So the data can be transferred by using these mediums. Okay, what are those? That is a message, sender. I mean, these are some components they are involved in transferring the message. Okay, message, sender, receiver, then communication channel or the medium, and encoder and decoder. Encoder and decoder. Encoder and decoder. So these are the main component. There are total 5 components are there in the data communication. So the next question is the method of communication in which the transmission takes place in both the directions, but only one direction at a time. Only one direction at a time. So that is called as hop duplex. Okay, only one direction at a time. So that is called as hop duplex communication. Okay, the method of communication in which the transmission takes place in both the direction but only one direction at a time is called as hop duplex. The protocols are, okay, the protocols, how we can define the protocols? Protocols are the agreement on how the communication components and a data transfer. Okay, agreement, it is in a protocol means it is a rule or agreement, rule or the agreement on how the communication components and the data transfer enable. Okay, error detection at the data link level. Error detection at the data link level, so that is achieved by the CRC code. Error detection, that is cyclic redundancy code. So there are 3 techniques that can be achieved to this for error detection. So that is a parity check, then checksum, parity check, checksum, and CRC, cyclic redundancy code. Parity check, checksum, and CRC. These are the 3 techniques at the error detection at the data link level. Okay, parity check, checksum, and CRC, cyclic redundancy code. Okay, so the next question. So here dash can detect the burst error of length less than or equal to degree of polynomial and detect the burst errors that affect odd number of bits. The burst error that affect the odd number of bits. So here the CRC the cyclic redundancy check CRC code. So it is an error detecting code that commonly used in digital networks and storage devices that can detect accidental changes to the raw data. Okay, changes to the raw data. So CRC can be used for the error correction, can be also used for the error correction. So the answer is CRC. And the design of CRC, cyclic redundancy check, the polynomial depends on maximum total length of the block that to be protected, that is data plus the CRC bit, data plus CRC bit. So the desired error protection features and the type of resources for implementing the CRC. Next, the question is that even asked in the ISRO, this particular question asked in the ISRO 2018, a station A uses the 32 byte packets to transmit the message to station B. From station A to station B, so the 32 byte of packets to transmit a message to station B using a sliding window protocol. The round trip delay between A and B is round trip. Okay, even acknowledgement also. So this particular round trip, okay, from A to B and receiving the acknowledgement from the B, and the bottleneck bandwidth on the path between A and B is 128 kilobits per second. So the optimal window size that A should be. So here this particular sliding window protocol, okay, so sliding window protocol that handles the efficiency issue by sending more than one packet at a time, more than one packet at a time with a larger sequence number. Okay, so the TT means that is a transmission delay. Okay, the transmission delay TT, so that is the time to transmit the packet from host to the outgoing link, that is from one source to destination. If B is the bandwidth of the link, then this transmission delay is the data divided by the bandwidth. D is the data size to transmit. Okay, so this is about the TT. Okay, so here in this case the data is how much the data A uses 32 bytes of packet, so that is a 32 byte divided by so here it is the bandwidth is 128 kilobits per second. Okay, so here we can see this, it is in byte, so just convert into bit, and this kbps to millisecond. Okay, so here we will get 2 millisecond. Okay, so that the transmission delay is 2 millisecond. Okay, then the round trip delay, that is the TP, is equal to 2 into TP, a round trip delay. Okay, so round trip delay is, that is a propagation delay. Okay, that is 2 into TP. So TP is so this particular round trip delay, that is they are given from between the A and B, so that is 2 into TP, this is equivalent to 80 millisecond, that is given, this is the given thing. Okay, and you have to calculate what is the optimal size of the window, optical window size that A should use. Okay, so that formula is T into T. Okay, the formula for this optimal window size is T into, that is TT plus 2 into TP divided by, okay, TT plus 2 into TP divided by TT. Okay. So the TT size is 2 millisecond plus, okay, so this 2 into TP is 80 millisecond. This is 80 and divided by 2, so that is 82 by 2. So here we will get 41. Okay, so the formula you have to remember. So that is the time delay. So that is a optimal window size. For optimal window size, the TT, transmission delay, plus, okay, 2 into TP, okay, this value divided by TT. Okay, so here we will get 41 and the near equivalent is 40. Okay, next question, the assuming for a given network layer implementation, the connection establishment overheads, the 100 bytes, and the disconnection, okay, connection means setup, for the connection establishment overheads are 100 bytes, then disconnection are 28 bytes. What would be the minimum size of a packet the transport layer that needs to keep if it wishes to implement a datagram service above the network layer and needs to keep its overhead to a maximum of 12.5 percentage? So here the solution for this is, for transport layer packet, the total overhead, so for connection established is 100 bytes and here it is 28 bytes, so for disconnection, so that is total 128 bytes. So the now question is, here it is the establishment overhead is 100 bytes and disconnections are 28 bytes. So what would be the minimum size of a packet the transport layer that needs, okay, if it wishes to implement the datagram service, okay, datagram service over the above network layer. So here this need to keep its overhead to a maximum of 12.5 percentage. Okay, so that is 12.5 percentage means the 12.5 percentage, okay, the 12.5 percentage is equal to 128, that is overhead they are given. Okay, how much percentage of the total packet, how much percentage of the total packet size that is contributing to the overhead in the entire packet, that is 128 bytes. So here you can calculate the n value will come around 1024 bytes. Okay, so that is how much percentage is equal to 128. Okay, so here the same the explanation. Okay, so total overhead is okay, 100 plus 28, that is 128. Since the transport layer wants to keep overhead to a minimum of 12.5 percentage, so 12.5 percentage of x or n, that is equivalent to 128. So this value you have to find, that is 1024. Okay, next. So next in cryptography, okay, so in cryptography the following uses the transposition cipher, okay, transposition ciphers, and the keyword here is layer. Transposition cipher, so explain the following message, spaces are omitted during the encryption, so that is a welcome to the network security, so that is the message. Okay, so this transposition cipher here, what you have to do, you need to write a plain text in a row of width L. Okay, so here the what is the width of layer means this particular cipher. Okay, so there are how many? It is L, the keyword, whatever the keyword given, the length is 5, right? So here what you have to do, you read it by the columns, and take the columns in a order defined by the key. Means alphabetically you have to assign the number. Like for example, here A is 1, the next comes E, that is 2, next 3, 4. So alphabetically you assign a number. Okay, so this is for the transposition cipher. So now you are assigned a number here. Okay, so next what to do, the plain text whatever they are given, whatever the given, what is the plain text? Welcome. Okay, so now what is the size width? The so the length is, the row width length is 5. Okay, so now read it a column wise based on the key, based upon the, this is the key. Okay, first you assign the number, then what to do, just write down WEL, so it should be 5, the size should be 5. Okay, so the size should be 5. So now WEL COME, then spaces are eliminated. Okay, 2 NET WORK, network security. Okay, network security. So this will come. So there are this, the width, the row width size is 5, so that's why you have to, each row the size should be 5. Now what to do, as per the based upon this value, like for example here the what is the first one, so this column wise you have to read, so that is EETSI, then second column is COOCY, third column is so third is this one WMEKR. Okay, so in this way you can just complete it, and the correct option is B. Okay, so this is the solution for that. Okay, so first you have to, the transposition cipher concept, that is you take the keyword, and as per the given keyword you write the numbers according to the alphabetical order. Okay, so that is for alphabetical order, one LAYER. Okay, so here this is 1 2 3 4 and 5. Okay, so then the size will be 5. Okay, so this is the way how you. Next, if the bandwidth of the signal is 5 kilohertz bandwidth and the lowest is 52 kilohertz, so what is the highest frequency? So highest frequency, so bandwidth equal to highest frequency minus lowest frequency. Okay, so bandwidth calculation, that is highest frequency minus lowest frequency. So highest frequency, they asked about the highest frequency, so what is the bandwidth? That is 5 plus 52. Okay, 5 hertz 50, so that is 57 hertz. So bandwidth means highest frequency minus lowest frequency, that you will get the bandwidth. Next, an Ethernet hub. It is Ethernet hub is called as a function as a repeater. Function as a repeater. Okay, hub is a network hardware device for connecting multiple Ethernet devices together and making them act as a single network segment. Okay, so Ethernet is a function as a repeater. A repeater is an electronic device that receives a signal and retransmit it. So repeater are used to extend the transmission. Repeaters are used to extend the transmission of the signal. Okay, that can cover the long distances. So Ethernet hub or repeater hub also act as a repeaters and regenerate the signals to avoid its loss. Okay, so Ethernet hub is a function, it functions as a repeater. The next question is phase transition for each bit are used in the phase transition. So phase transition for each bit are used in the Manchester code encoding. Phase transition for each bit that is used in the Manchester encoding technique. Manchester encoding, a logic 0 is indicated by 0 to 1. The logic 0 that is indicated by 0 to 1 transition, and logic 1 is indicated by 1 to 0 transition. So a phase transition, low phase, high phase. Okay. Then bit stuffing refers to the inserting a 0 in user stream to differentiate it with the flag. Bit stuffing. What is bit stuffing? It is mostly described insertion of the 0 bit after long run of 1 bits. Okay, it is just to differentiate it with a flag. If there are 5 routers, are there, and 6 intranet using the link state routing. So how many routing tables are there? Okay, so just keep in mind here, there are 5 routers means 5 tables. Okay, so the routers have the routing tables to transmit the packets selectively to other networks. So these routers, they apply the shortest path. Which technique? Shortest path algorithm to choose the links on which a packet is to be forwarded. So that it can reach the destination in covering minimum number of hops. So if there are 5 routers are there, suppose if there are 5 routers, then there should be the 5 routing tables. 5 routing tables as well. Okay, what is the one advantage? One advantage of demilitarized zone, demilitarized zone with 2 firewalls. Okay, as you know, the firewall that is mainly used for security purpose, so the most secure approach is to use the 2 firewalls, and the first firewall is also called as front end, that must be configured to allow the traffic destined to the DMZ, that is dematerialized zone. Second firewall that only allows the traffic from dematerialized zone to the internal network. Okay, so this allows dematerialized zone. Okay, the advantage is that the setting up of this dematerialized zone, that you can control where traffic goes in the network, control the traffic goes in the network. Which one of the following algorithm is not used in asymmetric key cryptography? So what are the symmetric key cryptography? The symmetric key cryptography are data encryption standard, that is a symmetric key. This is very important. Symmetric key cryptography, symmetric, asymmetric. Okay, cryptography, symmetric and asymmetric. So what are the symmetric key cryptography? That is a data encryption standard, advanced encryption standard, okay, AES DS algorithm, then blowfish, this is also symmetric key uh, cryptography algorithm, then triple DES, then two fish, blowfish and two fish. So these are the symmetric key cryptography algorithm. Then what are the asymmetric? What are the asymmetric key cryptography? Okay, what are the asymmetric key cryptography algorithm? So first one is the RSA, DSA. These are the asymmetric key cryptography algorithm. Then Diffie-Hellman Diffie-Hellman key exchange algorithm. Then digital signature algorithm. Then the Elgamal, that is also one of the asymmetric key cryptography. Okay, so here the option here you can see the Diffie-Hellman and RSA. Okay, so here which is not used in asymmetric. So RSA, DSA both are even Diffie-Hellman, these are asymmetric algorithms. Okay, so the symmetric is electronic code book algorithm. So electronic code book is it comes under the it comes under, it means it is not an asymmetric. Okay, electronic code book. So which of these is not a feature of WAP 2.0? So that is a wireless protocol for synchronization of wireless authentication protocol client computers and HTTP server. Okay, so here not a feature, that is hashing is not a feature of WAP 2.0. Okay, so wireless access protocol for synchronization of this WAP client computer to the HTTP server. Okay, so it is derived from the architecture of synchronization between the client and server. Okay, so that is push pop model, interface to storage device, multimedia. So it is a synchronization model. Then silly window syndrome, it is related to silly window syndrome. Silly window syndrome is related to it. Silly window syndrome is a problem in the computer networking that is caused by poorly implemented TCP flow control. Poorly implemented flow control. TCP flow control. So it degrades degrade in transmission control protocol performance. Okay, it degrades. So that is a problem in the computer networking. That is silly window syndrome. SSL is not responsible. Secure socket layer is not responsible for error detection and error correction. It is not responsible for the error correction and error detection. Okay, so secure socket layer is a standard security technology for establishing the encrypted link between web server and a browser. Encrypted link between the web server and a browser. Okay, web server and a browser. So this secure socket layer, this link ensures that all data passed between web server and browser, it remains a private and integral. Okay, it is a private and integral. Okay, so secure socket layer is an industry standard and it is used by the millions of websites for protection in the online transaction. Protection of the online transaction with their customers. Secure socket layer. Okay, it uses the HTTP protocol and to authenticate the web servers and to encrypt the communication between the web browsers and web servers. The standard for certificates used on the internet, that is X. Okay, then hashed message is signed by sender. Hashed message is signed by the sender using his private key. Hashing means here he is including his private key. Okay, after the generation of hashed message that needs to be transmitted over a network, so it is signed or encrypted by using his private key, the senders, that also generate the digital signature. So that message is transmitted along with the digital signature, which ensures the authentication, and non-repudiation. Okay, the range of the internet protocol, the IP address from 224.0.0.0 to 239.255 to 55.255. So this particular range of IP address, so it is used for multicast packets. Multicast packets. Okay, multicast packets. The 224 to 239 multicast address that represent the group of IP devices that can be only used as a destination of datagram. Okay, destination of the datagram, multicasting, not as a source. Okay, so 224 to 239, that is used for multicast packets. Then IEEE 802.11, so that you know, that is wireless LAN, wireless local area network. Okay. Then Dijkstra algorithm, that is used to calculate the routing tables, that is the shortest path that source to all the other nodes in the graph. Okay, shortest path from source to all the other nodes in the graph, and producing the shortest path tree using that, building the routing tables by building the routing tables on a network. Okay, on a network. So here from source to all other nodes, calculating the all other nodes, the shortest path. The subnet mask 255.255.255.192. So this extend the network portion of how many bits? Okay, it extends the default subnet mask for the class C. Okay, so this is for class C, and here 192, that indicates there is a two ones. Okay, so from these three we will get 8 into 3, 24 bits, 24 1, and here 2, so that is 26 bits. Okay, so that is a default subnet mask for the class C. On local area network, where are the IP datagrams transported? The IP datagrams that encapsulated in the payload field of Ethernet frame. Okay, and it is transported in the information field of the LAN. Okay, in LAN, IP datagrams are transported in the information field of the local area network frame. Local area network information field. Okay, in Ethernet, which of the following transmission media is not readily suitable to CSMA operation? Okay, so wireless medium can't be used. Wireless medium can't be used for the CSMA operation, as they are not suitable for the collision detection method. So a radios already have the large number of users and it can't detect the collisions between the senders and receiver. Okay, so the coaxial cable, optical fiber, twisted pair, so these are the suitable for the CSMA operation. So here the radio is wireless medium is not readily suitable for the CSMA operation. TCP sliding window TCP sliding window protocol that can be used to control the flow of information, okay, on a network, to transmit the information on a network. In sliding window, the sending device can send all packets within the TCP window size without receiving an acknowledgement. Next, what is the bandwidth of signal? That ranges from 40 Hz to 4 megahertz, 40 kilohertz to 4 megahertz. So what is the bandwidth? Okay, so the bandwidth, like highest frequency, lowest frequency. Okay, so here that is it ranges from 400 4 mega means we can write in terms of kilo, that is 400 kilo hertz minus the 40 kilo, so that is 3960 kilohertz. So 3.96 megahertz. Okay, 3.96 megahertz. Bandwidth means highest frequency minus lowest frequency. Which project 802 standard provides for collision-free protocol? Okay, collision-free protocol, that is 802.5, that provides a collision-free protocol. So here you can see 802.5, that this protocol is for the, it allowed only one token allowed to exist on the network at a time. Okay, so that provides the collision free protocol. And like similarly 802.2, that control, 802.6, that is a metropolitan area network, 802.6, 802.3 is a working group of collection of IEEE standards. Next, assume that each character code consists of 8 bits. Okay, then the number of characters that can be transmitted per second through an asynchronous serial line, 2400 baud rate with 2 stop bit. Okay, so here the baud value that represents serial port is capable of transferring the maximum number of bits per second. So the given baud rate is 2400. Sending the maximum of 2400 bits per second with serial port, the total data to send is 1 bit, that is at the start, 8 bit is the character size, and 2 bit for the stop bits. Okay, so each character code consists of the 8 bit. The number of characters that can be transmitted per second in asynchronous serial is at a rate is 2400. The stop bit is 2, start bit is 1. So 1 plus 8 bit plus 2 stop bit 2, so that is 11 bits. So there is a total data to send. Number of 8 characters that can be transmitted, number of 8 bit characters that can be transmitted is 2400 divided by 11, that comes around, okay, total baud rate divided by the start bit, stop bit, and total 8 bit is the size. Okay, 218.18. The network 192.78.41.0 is it comes under which class? So that is a class C. Class A is 0 to 127, class B is 128 to 191, class A, class B, class C 192 to 223, class 4 224 to 239, and class E 242 to 255. Class A, class B. Class A, Class B, Class A 0 to 127, Class B 128 to 191, Class C 192 to 223, Class D 224 to 239, Class E is 242 to 55. A physical topology of FDDI, okay, fiber distributed data interface FDDI. Okay, so it comes under the bus top this ring topology, FDDI, fiber distributed data interface. Okay, FDDI. So here you can see FDDI is a local network that can support thousands of users. Okay, so that is a ring topology. In networking terminology, UTP means what? UTP means unishielded twisted pair. So this question is asked in ISRO 2017. Unishielded, not uni, that is unshielded. Okay, unshielded twisted pair, that is UTP. Unshielded twisted pair. Unshielded twisted pair is the that UTP. Okay, due to so here due to its low cost, UTP, unshielded twisted pair. Unshielded twisted pair is extensively used for local area network. Okay, so these are the questions that are taken